Hi everyone and welcome back to the multiverse of 100 plus data science project series. In this video, you will learn how to build a rack system using DeepSeek R1. You will get the step-by-step guide with code examples, set of instruction, and best practice for smarter AI application. Now, what is RAG? RAG stands for Retrieval-Augmented Generations. Is a technique that combines the capabilities of pre-trained large language model with an external data sources. This approach combines the generative power of large language model like GPT-3 or GPT-4 with the precision of a specialized data search mechanism. That's mean in the RAG we are going to using here on external data source. It can be the PDF file, it can be the textual data, or it can be anything else. If you see the images, you can see that we having one user, and user can search and query to the retrieval, and retrieval is trying to searching something in the data sources. It may be the PDF file, it may be the textual data. Then based on the relevant search of the queries to the users, it will giving here some kind of relevant text. And after that, this retriever is trying to combining this query to the textual data and it passes to our large language model. So in this case, we're going to using here the DeepSeek R1, and then our large language model it is generating some kind of response. So this is how the rack system actually work. Now let's see the workflow of that, how we're going to building in this tutorial. So that's our project workflow, that is what I'm going to actually creating on here. So we're going to creating here one projects based on rack. So we have one users, and also we having one user interface. It can be the Streamlit, it can be the radio, it can be the Flux as well. And the user is actually asking any questions to the user interface. And inside this user interface, you need to upload here first one PDF file. So when you upload the PDF file, we need to extract it using this PDF plumber loader library. And when it extracts the data, document, it will pass in this data inside this semantic chunker. Because in the rack system, you need to first collect the data and then you need to split the data in some kind of chunk so that you can pass it to the large language model. And after that, we're simply going to store it inside a vector store database called FAISS. And also we need to store it in the form of embedding. So you're going to using here the Hugging Face embedding on this case. And after this data is going to store it inside our FAISS retriever. So when the user asks the questions to the user interface, and it will try to fetch here top 3 chunks of the data sources, and the DeepSeek R1 giving the response based on that. This is called the rack system. In the rack system, we have the data collections, we have the chunk, we have the vector store, we have the embedding, and we have our large language model. So this is how our rack system actually works. Now we're going to see that how can you use the DeepSeek R1 to creating here one rack system. So in order to creating here the rack applications using DeepSeek, we need to install here some of the important library just like the PDF Plumber, LangChain, LangChain Community, LangChain Core, LangChain Experimental, as well as the vector store database called the FAISS CPU. So let's install this by use a shift enter, or you can also using here this button to install this one. And you can see here requirement already satisfied. Okay, so you can simply going to clear the output from here, and after that I'm going to importing here all of the important module here. First I'm going to importing here the PDF plumber so that you can also importing here the PDF from our drive. Okay, or you can also access it from your content. So let's say from LangChain underscore community dot document loader. So that's called document loader. I'm going to importing here this PDF plumber, this PDF plumber loader. So let's say PDF plumber loader, and then from LangChain underscore experimental. That's experimental dot text splitter, because in the rack application you need to also split our textual data, importing here the semantic chunker. Then from LangChain underscore community dot embedding, we're going to importing here the Hugging Face embedding, because this is free to use. Okay, so Hugging Face embedding, this one. So you can see here importing here the PDF plumber loader, semantic chunker, and the Hugging Face embedding. Then we're going to importing here from LangChain underscore community dot vector store. Vector stores, we're going to importing here the files. That's a FAISS SS. Okay, this is the backdoor stored database where you can store here all of our important query in here. Okay, then I'm going to import, let's say, from LangChain dot prompt. So let's say prompt. I'm going to importing here the prompt template. Let's say prompt template. It should be the prompt template. So it's nothing but one template because our large language model actually understand the prompt very well. If you give it here one good prompt, it will give you the good results. Now let's from LangChain dot chains dot LLM. We're going to importing here the LLM chain so that we can creating here one chain of the large language model. So let's from LangChain dot chains dot combine. So this should be the combines document dot staff. So let's say staff. We're going to importing here the staff. Let's say staff document chain. Okay, so that we can creating here one chain of the document if you have. So let's say from LangChain dot chains. I'm going to importing here the last two underscore retriever questions and answer. Let's say retrieval QA. So QA is nothing but call question and answers. So let's use the shift enter so that we can import it. And you can see here all of the important library is imported correctly. Now we can simply go into loading our PDF file. So we can using on here, click on upload, and then you can selecting here our neural network.pdf. Because I'm simply going to using this one as my PDF applications, how our large language model is going to find tuned and try to getting here all of the data from here and how I ask a question from here so that it can retrieving the answers based on the questions that I asked. Now I'm simply going to using here this PDF plumber. Let's say PDF plumber, so that I can creating here an instance of that. Now inside that I can simply going to give it here my neural network .pdf, and this is nothing but my loader. Let's say loader. So let's say loader, and then I'm simply going to load it. Let's say loader dot load, and then I'm simply going to make it as a docs. So now our document is loaded. That's our neural network.pdf. So docs. So if you face any problem regarding to the voices, because I have some voice issue, okay, but you can see that how our document look like, it having some kind of file and authors. Okay, so I'm simply going to removing this out right now. And then after that, what I can do, in the rec applications, you need to also split our data, right? So I mean split our textual data. So for that, we're creating here an instance of the semantic chunker. Let's say semantic chunker, and inside the chunker you can passing here our Hugging Face embedding. So that's our Hugging Face embeddings. So and after that, I'm simply going to store it inside a variable called text splitter. So let's say text underscore splitter, and then I'm simply going to using here this text splitter to that we can split the text. Let's say text splitter splitter dot split document. Let's say documents, and then you can pass it to the docs. So this is nothing but for so that we can divide the textual data in a chunk so that we can pass it to our large language model. Because in our large language model, it having some token size that is taken by that is taken by the large language model. So that's why I need to split here the textual data with the embedding so that we can pass it to our large language models. So now this is nothing but our documents. Let's say documents, and then I'm simply going to shift enter. Now our document is splitting. It is, yeah, it's really taking time, not so much. If you have a big number of PDF file, just like the 500 or the 1000 data, so it will obviously taking time. But in here I just have the 21 pages, so it's not taking much more time. And after splitting the data, what I need to do, I need to actually doing here the embedding. So we need to initialize here our embedding. So let's say that's our Hugging Face embedding, and inside that I'm simply going to store it inside a variable. You can see that actually download lists like the Sundays transformers, the then the tokenizers and the vocabulary, all of the things. Okay, So now initialize our embedding. Let's say embedder. Okay, and then that's our embedding is loading. Now we can simply go into storing here all of the chunking data inside the back to restore database. Okay, that's our FAISS. Okay, so let's say fi FAISS dot from document. So let's say from documents, and we can simply going to passing here our documents. So that's our documents. That's our document. Here you go. That's our documents. And after that, I am simply going to passing here my embedding. That's embedder. So this is nothing but a vector. So let's say vector, and after that we can simply go into creating here this vector as a retriever. So let's say vector dot as retriever. Let's say as retriever. So inside that, you can simply going to passing here one search type. So let's say search underscore type. The search type is nothing but based on the similarity. Okay, based on similarity to the answers and questions. So let's say similarity. And then after that, I can give it here one search krwg. Let's say krg. So it's nothing but, let's say, first 3 pages it will checking this out and try to similar with the answer to the questions. So you can give it here k, let's say 3, so that you can do the 3 semantic charts on here. And this is nothing but our retriever. So let's say retriever. Now we have our back to restore database as well as we have the retriever. Now we're to actually using here our large language model. So I'm going to using here this DeepSeek R1. Okay, so if you don't know what is the DeepSeek R1, you can go and check out my videos of the DeepSeek R1 paper implementations. So in simply, DeepSeek R1 is nothing but one Chinese AI company, and this is a large language model is built by this DeepSeek AI company, and DeepSeek R1 is nothing but one version of that, right? And this DeepSeek R1 is nothing but using here the reinforcement learning without supervised fine tuning. So you can see we having the retriever. Now we're going to load it. So you can also using here the Olama in actually accessing here the DeepSeek, but in this case I'm going to using here the Grok Cloud API. So that's why I need to installing here the Grok Cloud. Let's say pip install LangChain underscore Grok. You can also using here the Olama. If you are using here your local disk, you can downloading this DeepSeek R1 version. It's really super fast, and it's the version. I mean, the size of the model is quite low. It's memory consuming as well as it also give you the first results. So now let's see how can you actually access this Grok Cloud API using this LangChain. Okay. Well, so that's our Grok Cloud dashboard. So you can just sign up with your email account so that you can get here this kind of dashboard. So you can selecting here your model. You can see here DeepSeek R1 distributed llama 17 billions. You can see, and also you can see Meta. Why? Because this model is distributed model. If you don't know what is distributed, just go and check out my videos about the DeepSeek R1s. Okay, so you can see here DeepSeek R1 this one, so you can ask the questions. So let's say what is LangChain. Let's say what is LangChain, and you can clicking here the submit button, and you can see here it having one word called think. Okay, in the DeepSeek R1 it actually thinking, it having a thinking capability. It's not yet called the actually prompting technique that actually using on here. Okay, in the DeepSeek. So you can see here it will give me the answer based on my queries. So you can go on the documentations. You can read about the documentation of the Grok Cloud. If I go inside these model sections, and if I go down, you can see here we having this model that's called DeepSeek R1 Distributed Llama 17 billion spec DACT. Or also you can using here this one, a DeepSeek R1 Distributed Llama 17 billions. So you can using this one, or either you can also using this one. So let's try to using this module. Okay, I mean these ones. I'm going to copy this name, and I'm simply going to go on here, and I'm going to importing here. Let's say from LangChain underscore Grok. I'm going to importing here the chat Grok, and then I'm going to creating here an instance of the chat Grok, and inside that I can passing here first my Grok API key. So to keep it here one Grok API key. So then I need to give it here the temperature. So temperature, let's give it here 0. And then I have to give it here the model name. Let's say model underscore name. So let's give it here the model name that is copied. And then now let's go on here again and go on the API key sections and create an API key. Let's say this is called, let's say DeepSeek. Okay, DeepSeek. And click on submit and just copy the API key and go on here and try to copy paste here the same code. So the temperature is nothing but this one. If I closing this one and inside the background section, you can see here on temperatures. Okay, this one. Okay, so now I am simply going to store it inside a variable called large language model, and then you can see here it's loaded. Now I can ask the questions to our large language model. So let's say invoke. So let's say what is Python, like a simple questions. You can see here the model DeepSeek R1 Llama 17B spec doesn't exist. You don't have access to it. Okay, we don't have the access of our models. So we can simply going to go on here and try to code the documentations and models, and we having this model. Let's try to copy this one. Okay, we have to copy this one because we don't have the access of this the new model one. Okay, so let's try to using this one. So this one. Now we have the access of this one. Okay, we don't have the access of the previous ones. So you can see here the think keyword, and that's our output that you can see on here. Okay, so that's been our large language model is actually working very fine. You can access our large language model called DeepSeek R1. You can also using here the OLAMA in order to access the DeepSeek R1 models. So now I am simply going to define our prompt. So let's say define prompt. So let's say prompt. So we need to writing here the prompt. So let's write our prompt. Let's say first number. So use the following, because you're asking the questions to our PDF file. So to giving here some kind of prompt so that it can working on based on that. So let's say use the following pieces of context to answer. Let's answer the questions question at the end. Okay. The number 2 is if you don't know. Let's say if you do not know the answer. Okay, just say that I don't know. Okay, let's ask questions about the psychological or the philosophy, which one is not available inside this neural network.pdf file. So simply you say that let's say I don't know. Okay, let's say I don't know. Okay, I don't know that. Okay, so but don't, let's say don't make up. Okay, don't make up an answer by own. Answer on your own. Okay, I mean don't taking the answer by your own. I mean because large language model also have the capability to keep the answer by own, which is not available on here. So I don't not actually answer it yet. Okay, the number 3 is keep the answer. Let's say keep the answer crypts and limit it to 3 and 4 sentences. Let's say 3 and 4 sentences. Okay, that's right. Now let's give it to the context. So let's say our context. So we need to have the context. Let's say context, and then we have our question. Let's say questions, and that's our question. And then we have the helpful answer. Let's say helpful answer. Okay, here you go. Now we're simply going to creating here one prompt template, so we can pass into the prompt template. Let's say prompt template dot from template. So it should be from, not example, actually from template, and inside that I can pass in here the prompt. and then you can simply going to make it as a questions answer. Let's say question answer chain prompt. Okay, that's our prompt that you define. Use the following piece of context to answer the question at the end. Then if you don't know the answer, you can also give it here this one. Don't know the answers. So just say I don't know, but don't make up the answer on your own. Okay, because LangChain model also have the capability to answer the questions by own. Okay, so don't know that. Okay, and after that we give it here another prompt. Let's say keep the answer crisp and limit it to the 3 and 4 sentences. Now I am simply going to creating here our large language model chain. So let's say LLM chain. Let's say LLM chain, and you can simply going to passing here our large language model. Let's say LLMs, and then in our prompt you can simply going to passing here prompt equal to question and answer chain underscore prompt, and then you're going to passing here the callbacks is equal to none and verbose is equal to true, so that we can see the progress. So let's true. So that's our last language model chain. So let's LLM chain, and then we can simply go into uh, creating here our prompt template for the documents. Okay, so you can simply go into using the prompt template. Let's say prompt template, and inside that you can pass in here the two variable. One is a page content, another one is a source. Let's say input variables, and inside that you can give it here the page content. Let's say page content, and then we can simply going to pass it here our source, and then we have the template. Let's say template, and our template we have the context. Let's say context. So let's say we can give it here. Let's say backslash and content. Okay, and our content is nothing but the page content, and then we have our source. Let's say backslash and source, and we can give it to the source itself. Now that's our prompt template for the documents, right? So we to give it here a variable name. Let's say document prompt. Okay, that's our document prompt is also ready, which are having this one. Now we can simply going to pass it to the stop document chain. Let's say stop document chain, and inside that you can pass in here the large language model chain equals to LLM chain, and inside that we have the documents uh, documents variable name. So you can pass in here the context. That's our variable name. You can see on here. You can see on here context, and then we're simply going to pass in here our document prompt. Let's say document prompt. This is nothing but our document prompt that we created on here. Okay, and after that we need to give it to the callbacks. So let's give it here callbacks is equal to none, and that's our combined the document chain. So let's combine combine documents chain. I mean, using this stop document chain, you can combining here these large language model chains to our context. Okay, this context, I mean this prompt and this prompt. Now we actually combining this prompt template as well as our this question answer prompt. I mean two prompt in a one single prompt, and then we simply going to run this out, and then we can creating here our retriever QA. Let's say retriever. Let's say retriever QA, and inside that you can pass in here the combine. Let's say combine documents chain is equal to combine. That's our the same variable name that you can see on here, and then you can pass in here the verbose. Let's say verbose is equal to true, and then we can pass in here retriever. Retriever is equal to here retriever and then you're going to passing here the return the source document, return the source document. Okay, source documents is equal to true. Okay, that's our retriever actually question and answers. So this is nothing but by question answer. It's a QA. And now let's running these ones. Now this is loaded. So you can simply going to give it here one user input. Let's say user input. Let's say what is sigmoid activation function. Let's say activation function, because this is available inside this PDF file. Okay, about the neural networks. So you can uh, actually ask some questions to our retriever QA. Let's say input, and then we can simply going to taking the result from here. Let's say result, and this is nothing but our response. So it's our response. Okay, response as response. Now that's what response is coming up. You can see here it entered to the retrieval QA chains. It will searching for this PDF file in the content of 15, content of 16. You can see that it will getting here some kind of questions and answer. And you can see here it will actually searching for 3 times because we give it here k is equal to 3 in the case of search KWARG. So we can simply going to getting here all the data. Okay, now we can simply go to printing here this response. Let's say response, and then you can see that's our response. You can see here this is nothing but about think tag. You can see on here, and inside this think tag it will try to think and try to do the self evaluations so that it can correct it again, and after that it will give me here the answers. The sigmoid activation function is a mathematical functions that map any real valued number of to value between 0 to 1. This is the formula of the sigmoid activation functions, and higher is the base of natural logarithm. The function is often used in the output layer of the neural network for binary classification tasks because it can be represented the probability. This sigmoid function has a S-shaped curve introduced nonlinear to the model, which will crucial for learning the complex pattern. Okay, if you want to learn more about that, what is the activation function, you can go and check out my videos. I have the activation function from scratch. So this is how this rack in the DeepSeek actually work. So you can also creating here one Gradio applications for that. Other Streamlit, let's say Gradio or Streamlit. If you are creating here these full applications in the local machine, you can using here Streamlit. If you are using this interface like Google Colab, you can also using here this Gradio lab architecture, creating here your web applications. So this is nothing but your homework to do that. Okay, so that's all about the rack in DeepSeek R1s. So I'll come up with some most interesting topic in this series as well. So just subscribe our YouTube channel and hit the bell icon so that you can notify. So thank you and bye bye.